Hey, hey!
Hi guys, does everyone see me? See my screen? Okay. Hi, my name is Yossef Vecsler. I'm a software engineer. I've been an officer in the military, not in the tech field, for 10 years. And then I went to my degree, and then now I'm 5+ years worker. I was a full stack engineer, and in the last year I became only backend. I'm working at Bywid. We are hiring, of course. And now this is a talk about WebRTC, which is a very, very, very interesting technology that came out like a decade ago. Um, um, let's see what it is. Okay. First, let's talk about a story I had back in the 2017. I went to work, and then I was introduced to the project, and they told me it was outsourcing. Now you are moving it forward. It was a consultant company which have a finance consulting, and they wanted to move everything online, like the clients, everything. It was before the corona came, and this is what they are there. So they had like 50% product, and they told me take it forward from here and make it full video conference with payments, with invoices, with everything. So I said, whoa, okay, let's see what it is. And this was my first introduction to WebRTC. And WebRTC, actually, I will just show you what it is. I think it will be better. Okay. So here in the left, I'm a client, which I've already came to the dialing screen, and from the right is the consultant, which is in the system. He's waiting. He can wait for calls. He just put his browser open, and this what was then. I can't show everything, but let's see what's going on, and I will try to explain. So. So now we are seeing it's the dialing, and 1 second you will see in the right you can see he's waiting for a call, and of course this video ahead of this video, and now he gets the call, and now we have a call. That's pretty much it. This is the WebRTC. WebRTC is a video over browser. 1 second we will dive in, but just that you will understand. It was, of course, with a payment. Okay, let's go for it. So, what's the problem that made the WebRTC guys to invent WebRTC? So, since the 90s, we have a protocol that called SIP. SIP was there was some Android. It was called, I think, SIPME, that you can call from it. SIP allows you to call a voice call, a video call, of course, with video, audio. I think also data can go there. So what was the problem that made the people of WebRTC to invent it? SIP, actually, you need to implement it in a software. So you need to install it, like Zoom. Zoom came in like a buzz or something like that. Everyone install it, and then you can use it. Now, then they made the support for the web browser, of course. And the WebRTC is actually, they said everyone has a browser. Why shouldn't us make the video and audio and data, everything in the browser? So we can, so if I want to dial to you, you want to talk to me, we don't need additional software installation, nothing more than than a browser. Phones have it, computers have it, everyone has it. So this is what made them to invent this WebRTC thing, and let's see what it is inside. So WebRTC actually is, as we said before, it's a real-time communication. It's streaming audio, video, and raw data. Why do I say raw data? 1 second, I will tell you. It's a real-time, of course. It's a very low latency. And peer-to-peer, when we say no server involved. When we say no server involved, which means I talk to you, you talk to me. But in order for our connection to start, we need a server. But once we are connected, once the WebRTC actually happens, it's only me and you. And I will show you something that I wanted to show you before, what's happening with WebRTC, which is a very nice thing. One of the components of WebRTC, which is, it's a component of the browser, but WebRTC uses it. So as you can see here, you can see my camera, and they made some filters on it. So I like this one. So you can make whatever you want with the filters, which is nice. But the thing is, it takes my camera, and with only the browser, I haven't installed anything, and it just takes me my picture, and you can play with it, send it to someone, or doing a filter or whatever. You probably know it from different sites that you have been into. Okay. So let's go on. The first thing about WebRTC that I'm talking in a high level. I don't know who is here and what's your background in programming. Maybe you're a starter, maybe you're a senior, maybe more. So I'm talking to everyone. Let's try to figure it out. Signaling. What is a signaling? Signaling is, let's say you probably have heard about a small program called Waze. So let's say I've been last week, I've been to Cyprus, and I wanted to get to somewhere there. Of course, I didn't know Cyprus. So I needed to ask someone how to get to where I want. So I have my place where I am, and I say, let's say the mall, and I want to get to the nearest mall. How do I get there? So you're pulling a taxi, and you said, okay, take me to the mall. Same happening with Waze. Waze is taking you to wherever you want. He's the middleman. So signaling is the middleman between the two parties. As you can see here in the picture, you have, let's say, a Chrome, one person using a Chrome, and another person using, let's say, Firefox or a Chrome. It's never mind, Safari, whatever. Now they want to talk to each other with a WebRTC. With WebRTC, I'm reminding, is a direct call. So when I'm talking to you, nothing else involved. So how do I get to know you? Where you are? How do I send to you thing? How do you send me your video? So we have a middleman. Who is the middleman? The server. Server, it's called the signaling. It signals to me, it signals to you, and it hooks up between us. So it's controlling terminating a communication session. So if you want to terminate it, if it starts, all the middle connectivity, it's based on the signaling server. So I went to Google, and of course I printed the signaling, and that's what, and I searched for the most complex picture I've found, which is a T-cell receptor signaling, which is what's happening in our body. It has nothing to do with WebRTC signaling, don't worry, but it was just funny to see it. It's the same idea, but it's not the same, of course. So let's dive in. We have a WebRTC API. Everything is an API. And the WebRTC API, it's in the browser, of course. It's implemented in the browser. So we have a media stream, peer connection, and data channels. We will explain it in a sec. So we have the media stream, which is what you see and what you hear. So we have the local media stream, which gets function get user media, and then you have the audio or video type, and you grant and you deny it. I will show it to you. I've made here a small page. You can see the code, nothing special. You have an ID and you have a video. Now I want to hook my camera and my audio to this video tag. So what I do? First, oh, it gives me when I did it already. So that's it. So I'm picking up the ID of the video, of course. Then I'm going to the navigator. Navigator dot. You have the media object, the media devices. Sorry. Now here you have all the media devices you have in your computer, and as we said before, the API is get user media. Oh, it do what it wants. Get user media. Now we pass here, what do we want? So if we want an audio, we say true. And if we want also a video, you say true as well. And then you're getting a stream. Stream is the stream of video and audio. And you pass it, let's see. And you have the video that we picked up before, this element, the video element. You are making the source object. Where is my source of the stream? And then that's it. As you can see, it asks for permission. The file wants to use microphone and it wants to use your camera. So let's allow it. Now I hear myself in echo. And that's it. Now let's stop it. How do you do it? We have the video dot source object dot. You can see there is a function get tracks. Get tracks give you can understand by yourself, an audio track and video track, which plays now. Now let's say I want to stop it. So let's take the audio because my echo kills me. And now I don't have an echo. And we take the video and we stop it as well. So everyone can do it at home. This is the start of an WebRTC. Every WebRTC starts with this, with getting the user media, and it's pretty simple. Let's move on. Then we had the peer connection. So the peer connection is an interface for the connection. Actually, it has some methods like you close is the simplest one. Like if you want to close the connection, you have the close connection. You can get the connection state, as you can see here in the code. You have the peer connection, and it says add event listener. Now you have an event which is a connection state change. So if the state of the connection has changed, it was okay. Now it became I don't know, it became failed or became disconnected or something happened. So it will take some few seconds. If nothing happens and you are not coming back online, it will hang up. So this state will change, and I will need to check what do I do in a failed situation. So maybe I close it. So I have the close, and then I can close the connection. So this peer connection handles. We will after that put it all together. But the peer connection handles the connection, of course. And you have last thing. You have the data channel. The data channel can transfer every data you want. What is it good for? You can play with your friend. If you are playing a game, which is a network game, you don't have to have a server in the middle. You can do it with a WebRTC, which is a direct connection. And even if Google falls down, No, if Google falls down, all the internet falls down probably. But if something happened to your server, then you can't play. Here, which is a direct connection, if both of the parties are good, the connection will move on. So it's pretty similar to the WebSockets if you used it before. Just or events, or so you send an event, you see you have a RTC peer connection. We talked before, this is the connection, and you create a data channel. You can see here in the line, you have a data channel, and then you can add event listener that listens to a message. Once a message comes, you're doing it with it what you want. This is the data channel, and this is the three parts of the API of WebRTC. Now, we're digging a little bit deeper, but it will be easy, don't worry. So we have three types of information that must be exchanged. Now we are talking about the session itself. So now we want to talk. What do we need to do in order to talk? So we need to say when to initialize the session, when to close it, and when to modify it. And there are some more things that we need to do with the session, but we need the control of information in the session. The control gives us, as I said before, close, modify, etc. Network data, where endpoints are located. I need to know where you are, and you need to know where I am. As I said before, if you want to get to the mall, you will need let's say you are driving, so you need someone to tell you what the address and what's the number or how to get there. This is the network data, and the media data, it's the codecs and media type. So I have the audio codecs, I have the video codecs, and the media data actually is the media data, what media and what codecs I will use, high quality, low quality, all that goes into the media data. So let's try to make it this a little bit closer to the reality. What's happening in the signaling server? So we have a few things we need to talk about. One is a NAT. NAT is nothing to do with WebRTC, but it's important to know it because WebRTC has. Let's talk about NAT, and then we'll explain. So the NAT is a network address translation, and it's used to give your device a public IP address. So let's say you are in your house, you live, let's say, with your parents or with your wife. You have 3 rooms in your house. You will not give, if you want to say someone to get into your house, you will not give him the address and you say room number 7. No, you're not in a motel, you're living in your house. You said you will give him the address. So every house is like it's a local network. So if a local network, let's say you are in your company, you have a local network, you are not exposed to the outer world. If you want to go to the outer world, you have a NAT. What is a NAT? It gives you a public. The company has 1, 2, 3 public addresses, and everyone use it. So I want to go out. I'm going to the NAT, say, okay, take it for me to YNet, bring me what's in there. So NAT goes, I am company X, give me the YNet, is going to YNet, bring the news back and bring it to me. So YNet does not know me, and the outer world doesn't know me. There is the NAT, which is the middleman. He's the door in the entrance of the house. So you know only the address. I hope it's understood. Then we have the ICE. ICE is one of the most important things in the WebRTC because it's a find a way for the two computers to talk to each other. So you probably know that you have firewalls, you have NATs, you have a bunch of problems that can happen that will not give you just go directly, or everyone to go directly to your computer. Otherwise, it will finish in a disaster, leak of information, etc. So you have ICE is the way how to find the way between me and you, and it uses 2 main servers. So you have the signaling server, which is a one server. and then you have the ice, which does is what it does is like that. It's going to let's talk about the stand server, and then you will understand everything, I think. So if you have a stand server, what's its duty? Its duty is to go and to give you the public address. So I'm peer B, as you can see in the picture, and you are PA, and me and you want to talk, but you are behind NAT. You are in your company. You sit in, I don't know, you work in Microsoft and Google, and you sit in your local network. You can't just go out. You are going to a stand server. You ask, who am I? I have a local address. What is my public address? I want to give it to someone that we can talk. So the stand server gives you the public address, and then you give it to the you're going to the signaling server and give it to your public address, and the signaling server hooks up between us. It goes to me and said, okay, you can find him there in this address, and me and you talk. It's finished. But what happens if you have a problem? There are some nuts that it's called symmetric nut, which won't let you won't let anyone to talk to you unless you talked to him before. So let's say you didn't call me, and because you don't know me, you don't know where I am. So how do I get to you? I can't get to you because you didn't call me. The NAT don't allow anyone to go to you to talk to you unless you talk to him first. So you have the turn server. You talk first to the turn server. You say everyone who wants to get to me, send it to me. So it's like the post office. Everyone that wants to send to you a letter, it's not directly to your house. It's going to the post office, and then the post office know where you live, and it gives you the letter. So turn server makes the latency of the conversation be higher, but it allows us to talk. So if there are a firewall or a NAT that don't allow it, so the turn server is a middleman who takes my stream and your stream and pass it between us, and then we can talk. I really hope it's understood. But one second, we'll see it in a code. So let's make a call. This is from the WebRTC.org site. It's pretty simple code. It doesn't contain everything in the conversation, but this is for making a call. So as you can see, the configuration is I give the ICE server, ICE means, which means stun or turn. How do I pass a NAT? So I have a stun server. In this situation, I don't have a turn server because there is no firewall. I'm at my home and no firewall in here, so I don't need the turn server. So I just don't put it. And you have you're creating a peer connection. As you saw before, you have a message, but now let's 1 second. We'll talk about 1 second. You have here the message that you are listening to, if there is a message, and about the offer, we can talk now. So the last thing in the WebRTC that will finish our WebRTC building blocks is the SDP. SDP is a session description protocol. So this is describe the multimedia session, which means it gives you a session ID, a title, what's the resolution. You want high resolution, you want a low resolution. Let's say I'm in, I don't know where, in India. Last time it was 10 years ago, but the internet connection there was not that good. So I needed, in this case, if I would have done on WebRTC, so the resolution probably was low. What are the formats, codecs, encryption, etc. All of this is the SDP. The security there is SRTP. You can Google it, and I will not talk about it, but you can Google it. And when I'm making in the last section of the code, when I'm making an offer, this is the offer. The offer contains the session. There you can see that here on the right, this is an SDP. You can see in the last 2-3 lines, you have the audio and you see the video. You even look higher, you have an email and a name, like for connection if you need. You don't always have it, and you don't need it in order to make an WebRTC, but it contains all the things that you need for the session itself. Now let's sum up the signaling process. I hope we are all good. And if no, now we will make an arrangement. We'll make the order of the thing. So you want to start a signaling process. What is signaling again? Me talk to you. How do we talk? So first you're creating an RTC peer connection, which says, this is me. That's it. Now I have an object which calls me. Now we're sending an ICE candidate. ICE candidate, as I said, to the other peer over the signaling server. So I said, as before, the ICE is how do I get to you? How do I get to you? So there is a queue dog which takes the ICE candidate and drives it to your computer. Then I am making an handler that when it gets your video and audio, it will hook it up to the video and audio on the web browser, as you saw before here. So this probably will be the handler. And now here I will get a stream which is not my stream, it's your stream. And there is another option to make a small camera here, small video, a video inside a video that in order that I can see, I will be able to see me. So this is the handler. Put your video in my video tag. Then the caller shares a UID to identify the call. We need a unique identifier. It can be whatever you want, your phone number. It can be hash. It can be whatever you want. So we need some identifier that we can identify the call inside the signaling server. So it's a server. He wants to know, okay, this is your call. This is his call. What's your identification that I can know that this is the call of you or in you? So we give him an identity as a UID or whatever. And the 5 is each peer connect to the signaling server. Now that everything is ready, all the data is ready, we are talking to the signaling server, and each peer tells to the signaling server that they want to join the same WebRTC session. So said, okay, I want this call, this UID call, and you say I want this UID call, and then there's the description, candidates, like it hooks up between us. It's sending the video information, the audio information, if you want the data, and then we can talk, and the signaling server is out. It's there always if something goes wrong, but from the connection itself is nothing to do with the signaling server. And now we've got to the interesting part. As I said before, WebRTC was meant for peer-to-peer. So what do we do with the multi-party? Like, okay, me talk to you, you talk to me, but what happens if I want more than one person? So this is where multi-party comes in, which is very interesting. But first I want to introduce to you my company, which we deal with WebRTC. And I want to show you a few things. Now we will see in a video of 25, I think, seconds. You can notice if you know now what is a WebRTC, which is a peer-to-peer, you can think of the problems that now what do we do? You are connected to me. I'm sending you my video. You are sending me your video. But what happens if we have 10,000 in one meeting, or I want to broadcast something? So our company, I will stop in the middle and I will explain. So as you can see, we have an influencers, which are Facebook influencers or Instagram or whatever. Now they have millions of stalkers. So who looks at their announcement, to look at their videos and everything. Now this influencer goes to let's say a Walmart, a live, and just present a product. Now it present the products. Now you can have, let's say, 10,000, 20,000, sometimes 50,000, maybe more people who are watching live in this WebRTC session and want to buy things. So what will you do? It's meant to be a peer-to-peer. So I'll show you the number that you will understand. So you have 300,000 visitors. You have a lot of product goes in the WebRTC session. One second, I will. So what did we see here? We have buying online in the session, in a WebRTC session. You can have, I don't know how many participants. You have thousands of products. How do you hold all that? How do you hold all that? Now, an influencer shows 1, 2, 3, 10 products. And you have 10, 20, 30,000 that move on a data channel wants this product. So you need to everything to move on a data channel that was meant, also a video that was meant to be peer to peer. So what do we do in such a situations? So let's see the architecture. Let's see the solutions. The first solution, it's called a mesh. A mesh solution is not the best solution for a big parties, but for a small, it fits. Like if you want to play a game and you are 3 or 4 guys and you are playing together, everyone can transmit it to each other, peer to peer, and your computer, your internet connection will probably hold it, and everything will be okay. And if you are transmitting only audio, you can hold up to around 30 people. So this is okay. Now, what do we do if we have 10,000? So let's go and see some other architectures. So we have the MCU, which is a multi-point control unit. This is unlimited. This is unlimited for parties. You can have as much as you want, but I will explain why. The stream goes to a server. Everyone's stream goes to a server. Let's say you have 10,000 people in one session. Everyone transmits video and gets video. What the server does is taking all the videos and audios, making from it, let's talk about 10, it will be simpler to explain. All the 10 videos, it's making a one video and it sends it to you. So it's encoding all other videos. So as I said, encoding the videos, I said a lot of compute power, and it is a very expensive solution, this one. But it's a good one if you need it. Of course, it's a higher latency because it needs to encode to take all the videos, making something in there like encoding, and to make one picture, and then it sends it to you. So you will be able to see everyone. Why? Because you are getting only one stream. You are getting one stream from the server, and you are transmitting one stream to the server. So everything is okay with you. The server will work very, very hard, and for scaling, it will be very expensive. Let's go to the last solution. Our last solution is a selective forwarding unit, which is SFU. So what can it do? It's up to 15, around 15 endpoints. Like it takes all the streams and it move it to you. But it's not that you don't need to transmit your stream to all other computers. You are transmitting your video and audio only to the server, and your server transmitted to everyone. So the incoming is from the server of everyone. If there is if there are 10 people in the meeting, you will get 10 video streams, but you will from the server, but you will transmit only one. In the mesh, you needed to also to transmit to everyone. So this is the SFU, and in our business, we're streaming only the influencers, so we don't need to collect everyone's video. So we are using SFU, which you take one stream and you stream it to everyone. It's a little bit more complicated than I said now, but this is for some other time. I hope you understood the three major architectures. Now you can imagine what problems and what challenges you have in the WebRTC in the big world. And that's it. I hope I hope you understand the concept and you understand the WebRTC, and of course, maybe we'll try it at home. Thank you very much. And by the way, we are hiring. Thank you.
Thank you, Yossef. So a very great talk about WebRTC. I have a few questions, and later on I'll see if there are some questions from the crowd. But first of all, you mentioned Matt earlier, and I get that with the Discovery server that supports those protocols, it's supposed to solve all your problems about NAT.
Yes, the ICE should solve all your problems about the NAT.
The ICE one. All right, and can you you can use some servers that are other on the internet, but can you have your own server?
Of course,
Is it difficult? You can, of course, but is it difficult to have your own server?
To have your own server? Listen, yes. Back in 2017, when I worked in the company, we had a lot of problems because of that. We tried to use some free servers, and it didn't go. So I called to Tzachi Lavont, which is one of the Israeli. You just look his number and just pick a phone. You never knew him before, so but you ask him, and he answered me, yes, there are a lot of problems with that. The stand server is less a problem. The turn server might be a bigger problem. So we took some service from outside.
Okay, paid, I think.
Paid one, of course.
Right, and finally, what architecture did your company choose?
SFU.
All right.
The SFU, which is I don't need the encoding because I don't have much of video streams. I have one stream which I need to everyone to see.
You collect only from the influencers, so you don't have that many streams to collect.
To collect, right? But to transmit, I have a lot. So yes, this is a good choice for me.
Great, thank you.